Welcome. In this presentation, I am going to give you a brief overview of what it would be like to study physics at Oriel College. My name is Julien Devrien, and together with Professors Andrew Wells and Andrew Boothroyd, we are the three tutors in physics and physics in philosophy at Oriel. One of the features of the Oxford approach that we are particularly proud of is tutorial teaching. And this tutorial teaching complements the departmental lecture courses and practicals that I will describe in more details in a few slides. The tutorial teaching at Oriel is done by college tutors, with some help from other tutors across the university. This is aimed to provide you, the students, with a tailored learning experience from experts working at the cutting edge of various domains of physics. At Oriel, the tutors belong to three different subdepartments of the university physics department, which is one of the largest in the UK, Europe, and the world. So these departments are, for me, astrophysics, for Professor Wells, atmospheric, oceanic, and planetary physics, and for Professor Boothroyd, condensed matter physics. As you can imagine, our research interests cover a wide range of topics. They range from the study of novel electronic, magnetic, and superconducting materials for Professor Boothroyd, who is shown as in this picture here, along with a levitating piece of superconducting material on the top left-hand panel, to for Professor Wells, the physics of ocean flows and their feedback on melting of the Greenland and Antarctic ice sheets. So this is illustrated by the cartoon at the top right, which shows a computational simulation of the flow of fresh water released by the melting. He's also interested in understanding the freezing of the polar oceans to form sea ice. And these are the images at the bottom of the picture, where the computational simulation this time shows salty plumes draining from growing sea ice. As for me, I study how the large-scale structures that we see in the universe today, which range from superclusters containing thousands of galaxies like our own Milky Way, as illustrated in the top right panel of the picture shown on this slide, to individual dwarf galaxies, which is the top left picture, how these structures emerge from a quasi-homogeneous state that the universe has right after the Big Bang. And I am curious to how they end up distributed in the so-called cosmic web that you see on these images. As I briefly touched upon earlier, the way physics is taught at Oxford is split between lectures and labs, which are common to the whole university cohort, which is about 200 students, and tutorials, which happen in college and where the students are split in groups of 2 to 3 people to work out problems that are related to what was taught in the lectures. And this happens, of course, with our college tutors that I've introduced in my previous slides. So in practice, there are technicalities which you will be made aware of in due time if you decide, as we hope you will, to come study physics at Oriel. But here, I'm going to try to give you a broad brush picture of what the current physics course looks like. So in the first year of physics and philosophy, you'll cover a wide range of physics topics, from mechanics, optics, circuit theory, electromagnetism, to special relativity. Along with this, you'll learn the mathematical methods that will be useful to you in physics, such as linear algebra and differential equations, to multidimensional and vector calculus. There will also be short options that you can pick to explore a particular topic of interest, like astrophysics, quantum ideas, or functions of complex variables. In the second year, your main courses will feature statistical mechanics, quantum mechanics, electromagnetism, and optics, along with more advanced mathematical methods. More short options will be available to you, like climate change, biophysics, medical physics, or exoplanets. In the third year, you will be required to choose courses amongst condensed matter, subatomic physics, special relativity, fluids, atomic and laser physics, general relativity, and advanced experimental and computational projects. More short options will also be available in the third year, such as the history of physics or sciences, numerical methods, advanced quantum mechanics, or plasma physics. Finally, in the fourth year, should you elect to do a four-year degree, you will again have to choose options amongst, this time, astrophysics, atmospheric physics, particle physics, condensed matter, theoretical physics, lasers and quantum information processing, and biological physics. Finally, in all years but the fourth one, lab sessions will run in parallel to the lectures and the tutorials. You can find a much more comprehensive description of this course on the physics department website, and I will give you the link on the last slide of this presentation. Let me tell you a word about physics and philosophy students now. Oxford University admits about 200 physics and philosophy students per year, and out of this yearly cohort, at Oriel, we typically admit 7 new students. 5 of these in physics and 2 in physics and philosophy. As I previously mentioned, different tutors teach different parts of the course, but what we try to do at Oriel is to make sure that all the students are taught by all 3 college tutors in each of their first 3 years of study. To give you a little bit more of an idea of the balance between lectures and tutorials, lectures on a specific physics topic, like quantum mechanics or thermodynamics, range from 10 to 20 hours throughout the year, and the tutorials associated with them happen with a frequency of once a week or fortnight during term time. Finally, you'll spend about several days a year in the lab running experiments which are connected with the lectures, and that only in the first 3 years of your study. Let me give you a word to conclude of what we look for when we admit physics students. First and foremost, we look for candidates that are passionate about physics. We test for their ability to express physical ideas with mathematics, and how clever they are at reasoning and solving problems. They also need to have a keen physical intuition and be able to communicate their results in a clear manner. If you have any question, please don't hesitate to get in touch with the Oriel admission office, and do not forget to visit the Physics Open Day page, which is given, the URL of which is given in this final slides. Well, thank you very much for your attention, and hope to welcome you soon as a physics student at Oriel.